It's all good. All right, guys. Here we go. We're getting it started now. Welcome to RITSEC, guys. Week 3, Security through Community. Make sure you join the Discord if you have not joined the Discord, because you do need to sign in order to get pizza. Everyone all in? All right, guys. Make sure you sign in now, because I'm going to be checking later when you guys want pizza. You must be signed in or else you're not getting pizza. If you guys don't know where that is, raise your hand. All right, guys, check the calendar. We got some cool events coming up, which I'm about to announce right here. What? Oh, yeah. Guys, we got to drop the sign in if we didn't know that. Where's my fellow e-board? Who could do that? Uh-oh. All right, guys. Sign in will be dropped. Will be dropped in a second, okay? But let's keep going. So check the calendar. Make sure you join the mailing list as well. And here's for announcements, guys. Clap it up for the sponsors, guys. Come on, clap it up. Clap it up. Let's go, let's go. All right. Make sure you follow our social media. And we have IRSEC Black Team signups. Right now, they need to fill in scoring and store. In the competitions on November 1st. And this form closes on Monday night. Same thing with Blue Team. Yeah, the Blue Team workshops are being held throughout the week before the competition starts. You guys can join in as a team of 5, or you could be a free agent, and you could be assigned to a team. So make sure you guys get on that. Yeah. When did they close? I'm putting the slide, so I have to check back. It's in the announcement on Discord. Yeah. Message Ariana about that, and sign up as 2, and then say like we signed up as a team as 2, and we're looking for free agents to fill up the rest of the team if that works. If you guys get selected, they'll fill up your team, but that should definitely be made to happen. And yeah, CCDC info session happening after the meeting today. That's right, James, right? Okay. Make sure to check that out. Be there. Now we have Intro to Linux by Odessa. Clap it up, guys. Clap it up. Good presentation coming for you.
Hello. My name is Odessa, and I'm doing Intro to Linux today. So, starting off, who am I? I'm Odessa, she, her, third year CSEC. I taught Ducky's mentorship last year and was a Ducky mentee the year before. Hopefully current Linux Black Teamer. I'll ask Ash later. Enjoyer of loud music and live music. Go to way too many shows, including this weekend and next weekend and the weekend after that. I daily drive Void Linux, which if you've never heard of, congrats. Good job. You shouldn't hear from it ever. And this will hopefully be the only time I mention it this presentation. Go to VRig. Big VRig enjoyer here. And I also use Windows, much to some people's surprise. So starting off with some background. What is Linux? Linux itself is a kernel, open source kernel. It is not an operating system. You have different Linux distributions that sit on top of the kernel, and those are your operating systems. Some of these include Ubuntu, Fedora, Kali, Arch, and shout out to Garrett, the sysadmin professor, Red Hat Enterprise Linux. Shout out to Garrett, physical lead too, I guess. Why use Linux? This is a question I get asked all the time. For starters, it's open source. That means all the packages, most of the packages and the kernel and most of everything is out there online for you to look at. You can go look at the source code, you can go poke at it, write your own versions of it. It runs on everything. Mainly what people use it for are servers, but you can get it to run on any ancient laptop, any ancient computer you have lying around, or even your car. If there's a processor, it can probably run Linux. Linux is command line focused, meaning that you can do everything that you could in the GUI from the command line. This is also possible with other operating systems like Windows, but in Linux, it's intended that you use some of the command line for everything. Some of your Linux experience will be only command line when you don't have a GUI at all. You have a lot of different package managers. It's how you get different packages, different programs to run. Some of the main ones that you'll encounter are apt, DNF, and PKG. Pacman if you run Arch, but most people don't. And it's a multi-user session operating system, meaning multiple people can be using one machine at the same time without running into each other. This is really useful for servers. Not so useful with your personal computer, hopefully. But again, servers is where Linux really shines. So diving a little bit deeper into the shell, it's what allows you to access the internals of your operating system. A lot more powerful than most GUI tools. Most GUI tools are sort of wrappers for what you can do in the shell. Some examples of shells you have are Bash. That's what comes pre-built with most operating systems. ZSH, it's a popular Bash alternative. Allows for a bit more customization than Bash. You can do some cooler things with it. SH is very basic shell. If you ever get unfortunate enough to be dropped into TTY1, you're going to be dealing with SH. And then my personal favorite, Fish, which has the most amount of customizability of any shell I've found, but also deviating a lot from what Bash sets up. So your prompt, by default, will give you some basic information. It's customizable in a config file called your bashrc or zshrc. For example, mine on my laptop is Odessa at void. Odessa is my username. So depending on which user I'm logged into, that will change. And then void is the host name of the machine. And then next to it, that little tilde, that will get replaced with my path, or my current working directory, I'll say that. And you can interact with the shell through like the default built-in shell, but normally when you exist in userland, you'll interact with it through your terminal. By default in Ubuntu, that's the GNOME terminal, but some alternatives are Kitty, WesTerm, Console, and Tmux. I know there are Tmux enjoyers here. Not a fan myself. So in the shell, who, what, where, what's going on? To start off, there's the ID command. Type that in, and you get your user and group information. We'll go deeper into what groups are later, but this has a lot of different information about who you are, what permissions you have. The pwd command stands literally print working directory. It'll print out exactly where you are in your file system. IPA. Oh, no TAC A, interesting. IPA, it shows network information, your IP address, different things that you can use if you're diagnosing network issues, which you will be. And PSOX, this is used to look at process information. So what processes are running, who's running them, their process ID, parent processes, how long they've been up, permissions the processes have. Very good for diagnosing issues if you don't know what's going on. What does this do? So there's these things called man pages. For every command, there should be a man page associated with it. And to check it out, you type in man and then the command. Very simple. Think of it as built-in documentation in the machine itself. You don't need internet access for this. It's all locally on your computer in user share man. And it's really good because that is how you figure out like what all these different options do for different things. Something else you can do to figure out what commands do is the command apropos. If you type in apropos and then a keyword, it will print out everywhere in the man pages that this specific phrase exists, like every page that has that phrase in it. So if you type in apropos SSH, for example, it will put out a list of every single man page that has SSH in it, which can be really useful. So that's a basic overview of everything you'll be doing in Linux. Start diving deeper into the file system. So the Linux file system exists in a tree-like state. You'll see it shown different ways, but it all starts from your root directory, which is the slash. Inside your root directory, you have a bunch of different root level directories. We'll get into some important ones later. Your etc one is really important, etc. But from there, everything is a file. Although you can change directories, those are files. You can look at different files. Sockets are files. Processes are sometimes files. They're a weird state when they're running, but from your root directory, everything exists inside of that you can think of on Linux. And just some terms. Relative paths are paths to different places in your file system, starting at where you currently are. So if I was in a directory in my pictures directory, I would go back one to go to my pictures directory, back one to go to my home directory, and then I could change into whatever directory I wanted that's in my home directory. This differs from absolute paths where you start at your root directory, you start with the slash, and that will take you directly there from wherever you are. So going deeper into paths, once again, you have your slash, which is your file system root, the etc directory, pronounced etc, or etc. It confused me the first time I heard it. It's where all of your, most of your configuration files will be for your system. You'll end up here a lot when you're debugging weird processes. Your home directory is where all of the different user directories are. So, for example, like when you log into your student account on RLS and your whatever VM you have, when you open up the terminal, you will be in home/student. Your proc directory has information about what's on your system, what's running on your system currently. You can dive into that deeper to find out more. The /bin, /userbin, /sbin, and user sbin contains all of your binaries, all of your different commands that you can run. That is where they all live, or should all live, ideally. They each have their own specific use cases of why something would be in bin, user bin, but for all intents and purposes, you don't really have to worry about that. Those four are where all of your binaries will be. The var log directory is where a lot of your system logs are going to be. A lot of processes by default create a directory in there to send their logs to. Logs can be annoying to read, but I promise you they will be very useful later. Yeah, the tilde, the little squiggle, that is what's known as your home directory. If you see that in your terminal, you're in whatever user you're logged into, their home directory. That's where downloads, documents, pictures, desktop, music, and videos will be, those defaults that you're used to seeing. And about the relative paths. The dot, the single period, that is your current directory. That's where you are. And ... is one level up, so the directory before where you are. Navigating said file system. CD stands directly for change directory. If you just type out CD, you will go back to your home directory by default, but CD downloads will take you to downloads. CD ... etc will take you to the root level etc directory from your home directory. The ls command lists everything in a directory. It's how you see what's in there. ls-tac a lists all the files, including the hidden ones. ls tac l gives you additional information about each file in each directory, for instance, who can access it, who can read it, and la for both. The cat command prints out the contents of a given file. Syntax is cat file name. It's very simple. It's how you can read a file without actually having to go into an editor to open it up. Other methods to do this, you can do some stuff with echo. The less command will show you certain lines. The head command will show you certain lines. Importantly, the file command, just typing in file and then the name of a file will print out exactly what type of file it is. So in the image up there, I ran all these commands in my home directory. So cd to get back to home, ls listed out all the directories in my home directory, or all the files rather, in my home directory. I have a file in there called example. So when I ran cat example, it printed out the 2 lines in that file. And then when I ran file on example, it's telling me that it is a bin bash script, an executable. A very important tool you will learn somewhat how to use is the find command. This is how you can locate any string on your file system anywhere. The syntax is find, and then the starting point, and then whatever options you want to give it for how you want it to search. Listed out a couple of these ones here that you'll find useful, but the man pages are definitely your friend for this. There are a lot of different options for find. It's a very powerful tool. So starting off, the tac name just lets you search for things with that name, or iname. I'm pretty sure that is in the name, so a bit looser, but still when you're searching for a string. Tac type allows you to search for files of whatever type you specify. So executables, config files, videos, you can filter, essentially how it works. Tac perm is searching for different permissions. We'll go into what permissions are a little bit, but essentially think of it as who can access what and how. So you can search for files by specifically what permissions they have. You can search for them by the user or the user ID. Find files owned by this specific user. Same with group, owned by the group or that group can access. And then tac mmin is find files that were edited within a certain amount of minutes ago. And the which command allows you to find exactly where a binary is on your system. You run which and then whatever command you want to find. This is where you can find if it's in user, user bin, or bin, user bin, sbin, user sbin, those 4 directories. Diving more into users and groups, it's how access control is handled for Linux systems. Each user has a specific number associated with it. That's the user ID. Among other places, this information is stored in etc password and etc shadow. As you can see in the first screenshot, that is the first line of my etc password. You can see root and its user IDs, which are 0. And also the default shell that it uses when you log into it. For me, that's fish. By default, I believe it's sh, but you can go in and change that. For groups, every user has a primary group that's associated with it, and then you can add up to 15 other secondary groups, and each group works relatively the same. They have their own ID, and they're how you organize different users. So for instance, the users that people log into, we're using the word users a lot, but those specific users will all be in the user group. Whereas you'll have the Docker group or the sudoers group, for instance, and the Docker group can control Docker and use Docker commands. Sudoers group has access to the sudo commands, so you can do things as root. And all that information is stored in etc group. Continued going on to sudo. Sudo is your super user. It's how you can run commands as root. Root can do basically anything on your system. Anything in userland it can do. It's configured in the etc sudoers file. You can edit that using vi sudo, I believe that's the command. And sudo tac-l is how you list the privileges, what you can do for the current user you are logged into. Some helpful commands for users and groups are usermod to help modify some specifications of the user account, so like what permissions that user has. Useradd is how you create a new user through the command line. Userdel is deleting one of the users from the command line. Groupadd and groupdel, same thing but for groups. Chmod or chmod, changing file permissions, changing it to be executable, changing who can read it, who can write to it. And chown or chown, changing the owner or the group of the file. Going more into file permissions, this is how you specify what users and groups can do what to a file. So here we have an example. In yellow is the type of file. So it's a directory, a link, or normal. If you look in the screenshot, this is a file. This is a directory in my system. We have in there, you can see the string at the front where it's RWX and all the dashes. For the normal files, it's just the dash. For directories, you can see the D, and for the symlink, which we aren't going to go into in this presentation, it's an L. They're a little weird. The first 3 letters of the permission string are for the owner. So what the owner of the file can do, you have read, write, and execute. The second 3 are for what the group can do, the group that the user is part of, the main group, so read and write, but not execute in this case. And then what's in red is what all the rest of the users on the system can do, and that's just read. So in this case, if that's my personal account and I am in the users group, I can read, write, and execute whatever file we're looking at. Other people in the users groups can read and write, but they can't run that file. And any account that isn't in the users group, so like if for some reason someone in the Docker group, only the Docker group is trying to, or that account is trying to execute the file, they won't be able to, which is good because no one should be using that. Yeah, file permissions will also be very important for later. Interacting with files, mv move is how you move files around and rename them. rm is for removing files. cp, copying. You can copy files and directories. mkdir is for making a directory, literally make dir. Less allows you to scroll up and down through the file. Pretty sure that uses vim keybinds for those who know what that is. Tail and head, you can add a tag number after them, and you can output the first number or the last number of lines in the file. Useful when you don't really want to have to scroll through a massive file and you know exactly what the lines you're looking for, where they are. And then once again, the file commands to determine the file type. Yeah, and then we have a bunch of examples on the side. Can we move this? Yeah, so top screenshot, I use the command mv readme.md flagmd. This moves, or it moves the file from being readme.md to flagmd. That's how renaming works. Little confusing, a little weird to grasp at first that you're moving the file, but it's just the syntax. Once again, running the command, the cp, copying, in this case, my binary ninja executable to be Ghidra as well, binge on top. Checking the file for, in this case, a Windows executable on my Linux system. Don't know why that's there. Nothing bad going on. And then at the bottom, it's an example of the tail command. I'm outputting the last 10 lines of strings.txt in this case. grep. Grep is similar to find in how powerful it is, but in this case, you would be searching for strings itself, specifically patterns in a file or patterns in whatever you are pushing into it, whatever you're sending to it. It uses regex, which I don't know if you've encountered that in your intro classes yet. Very weird syntax, not at all beginner friendly, but there are a lot of resources out there, specifically regex101.com. You can make and test out different regular expressions. And these are just here to help filter and edit, almost automate the editing of text. It's very useful for log files, specifically when you're searching through massive log files to find certain strings. If you figure out the correct regex string to write, you can filter everything down to exactly what you want to read. Grep can take redirected output, so listing or catting a file, printing it all out, and then sending that output into grep just to print out certain lines. I use this all the time. And ripgrep is another command that you can use that used to recursively search a directory for a pattern. So it sort of exists between find and grep in this case. Has Unicode support. It's faster. Check the man pages. You'll learn all you want to know about it there and more. Going into some other stuff, some processes, some other things you'll find useful about Linux. SSH. It is the secure shell. It's how you can connect to different shells. In cyber, this is really useful in general, getting access to different machines without having to go up to them physically to log into them. You can install them, I think sudo apt install SSH is how it works. I don't know. I don't use Ubuntu anymore. But you can install it and set it up. It works pretty much out of the box. You do need to set up some configs to fit your system, but once again, it's pretty simple. The syntax for it is SSH username at host. So going back to my original, way back when I showed you my own username and host. In this case, Bingus1 is one of my servers. And so SSH Odessa, I'm logging into the Odessa account on that host. And by default, this runs over port 22. By default. It can be changed. It might be changed. By default, it uses password authentication. So when you run SSH, it'll have you type in the password of the user to log in. But you can set up to use public-private key instead for instant login. It's also way more secure. The command SSH keygen is what you use to generate those keys. Once again, check out the man pages. Just play around with it. It's very simple. Different file editors. Starting off, you have VI and Vim. Vim is literally VI improved. VI comes default on your machine. Vim you have to install. They are optimized for being able to use your keyboard, so they're a little weird because they have different modes. You have insert, you have visual, and then there's one more. I don't remember off the top of my head. Not super user-friendly, but once you get the hang of it, it's really powerful, really useful. By default, most of you will be used to Nano. It is the most user-friendly. You can use arrow keys in the editor. By default, you don't have to change modes. You don't have to do anything. It's just by default, you can edit whatever file. Not necessarily a competitor, but an alternative to VI and Vim is Emacs, arguably more powerful, also hard to learn and get used to. You'll find people who prefer either. I know there's someone here who prefers Emacs. Don't think he's here right now. NeoVim is an editor you'll find some of us in the club preferring. It's Vim, but with a different backend, so it's a lot more configurable. You can do a lot more with it. Talk to Michael Brenner about his NeoVim config, please. I know there's another text-based editor called Helix. I've never used it. I just put it there because it sounded cool. VS Code is a perfectly fine text editor to use. If it's what you're comfortable with, you can launch it from the terminal. You can use it. People will try and shame you for it, but don't let them. It's perfectly valid. And then on Ubuntu, you'll have gedit, which is GNOME edit. If you just by default open a file, that is what you'll be dropped into normally on Ubuntu. Also important, pipes and redirection. Pipes were mentioned earlier in the slideshow. It's how you take strings and move them in and out of being used in commands. So by default, I'll just give examples. So the single caret is the single and double caret are how you take an output of a command and send it to a file. One of them overwrites everything in the file. One of them adds on to the end. I don't remember which off the top of my head, so you'll want to check on the man pages for that, probably. Yeah, so you can see examples down here where you run the find command and then send that to output.txt. The left-facing arrow can be used to input file contents to a command. There are other ways to do it, specifically with the pipe, the big line that's above the enter key or the return key on your keyboard. That actually has a use. And it's how you can take output of a file and then use it in another command. So I said history in grep. In this case, the example is ls-tac-la. And then you take that output, that listing, and then send it to grep for some file or text or some string. Environment variables. At first, I didn't really learn a lot about them, and then they became the bane of my existence. It's how you can store information essentially as variables on your system. There are two kinds. There's the global environment variables, so those apply to everyone on your system. In this case, they can be set on user login through system-wide configs in etc profile or etc environment. And then you have user environment variables, and those are normally set in your shell config. So your bash RC, going back to that, you can set different variables that you'll use in there. For example, your path. For anyone who's ever fought with VS Code on Linux and says something about your path is an environment variable that you can add different strings to. For setting them, you can run the export variable in all caps and then the value, or just the variable in all caps and then the value. And unsetting it then removes it. Again, these aren't important until they suddenly are, and you will not expect it, or at least I didn't. Processes. Went a little bit into processes earlier about how they're files, but not exactly files. There's some weird in between. Processes, they're what's running on your system. So in this case, PS, the command PS, shows all running processes and related information. It reads from /proc. Very useful. It's a really useful command. Again, useful for later. Pay attention. Yeah, you'll need it to look at what processes are running, what users started the process, how long they've been running, their path. Then for the opposite, killing a process, something you do occasionally need to do when they aren't set up correctly. It just sends the syntax is kill and then the process ID, although TAC9 forces it, so kill TAC9 and process ID, that will force it to be killed. It won't be able to argue. That is just how to get rid of a process completely. Very, very useful. And then you have a top command, which similar to PS, but top is live. Actually, I don't know if PS is live. Whatever. Top is a bit more interactive. You can check more information about what's currently going on. Some alternatives are HTOP and BTOP. They allow slightly different views, but they're also separate packages. So by default, top, you can check user, the PID, the time that it's been running for, the specific command that is running the process, how much CPU and how much memory that specific process is taking up. Yes? Similar in its use, yeah. So the question, is top similar to Task Manager on Windows? And it's not a mirror, but they're used for the same things. You can also kill processes from top. So if you don't want to deal with the kill command or finding the PID or searching for what's going on, you can run top and you can kill processes directly from top. Going a bit more into package managers now, again, just going through some useful stuff. It's how you install and update your software on your computer. Packages often have dependencies, and so your package manager will help you also install those dependencies with the package you want to install. By default, Ubuntu uses apt. Rocky uses DNF, I'm pretty sure, or PKG, maybe both. Misspelled that there, but Pacman is what's used for Arch Linux and all the Arch derivatives. To update software, apt update and apt-get upgrade. Apt-get is a related package, but used for the same thing. DNF upgrade and whatever Pacman string it wants. Downloading files from the command line. So again, sometimes in Linux you don't have a user interface. You don't have something you can click on. So in this case, if you need to get a file, you can use wget or curl. Wget, it's extremely simple. Just wget and the URL. So for example, if we're downloading from a file server that's hosted on example.com, if you want a file or to the file.txt, it's just wget and then the link. So example.com/file.txt. Curl is a bit more powerful, a bit weirder. You can use this to directly save. You use it to read strings from servers. You can use the tac-o command to specify the file that you want it to end up as. So you pull a string down and then you send it to a file directly. I prefer curl. They each have their own use case, but learning curl is also very useful. Some tips and tricks for just moving around, getting stuck in the command line. Control-C kills the current command. If you run a command and then it just freezes, spam Control-C. It'll kill it, it'll stop the process, it'll get you back into an interactive mode. Control-D is exit. So if you're in your user interface, that's how you exit your shell, you close your shell. If you're in a TTY, or this is also how you log out of certain users. So if you're in a user and you want, say you change your user to root and you want to get back to your system user, Control-D runs the same thing as log out. Just a quick, easy command. Control-I on some terminals is how you clear whatever's in there. It works as the clear command. Control-Z is suspending a current process. If you play with Python shells, it tells you to escape is to use Control-Z. You can use FG to run in the foreground and BG to run in the background again. You can list your suspended processes with jobs. The tab key, it's how you can autocomplete things. On some shells, if it's set up right, you'll be able to see a preview. By default, you won't. So you just hit tab, and then you can cycle through the list of all the things that you can autocomplete with. The history command is how you check all the commands you've run so far that have been cached. And then Control R is, it'll give you an option, it'll give you a prompt where you can search through your history and see different commands that have the string that you typed in it. More tips and tricks. 2 exclamation marks is rerunning the previous command. Sudo 2 exclamation marks is rerun the previous command with sudo. Not in fish, but in most other shells, this works by default. Exclamation mark 5 reruns the 5th command from your history, and you can extrapolate that to whatever number you want. Exclamation mark thing, or string, whatever it is, reruns your most recent command starting with that string. Caret this, caret that, reruns your previous commands and replaces whatever the first string with the second string. $, exclamation mark. The $sign is how it helps you deal with environment variables. So returns the value of your previous command. And then alias is how you set strings to do things. You can set aliases in your bash RC for them to persist, but otherwise you run alias, the string, and then what you want it to do. So in this case, with the example, that would set the command ls to be power off tac p0. I've done this before. I did not like that machine. And to end things off, more resources if you want to dive deeper into Linuxes, because this is very much just an intro. You can check out previous year's presentations on the Rybski YouTube. You can check out the Linux kernel documentation at this link here if you want to read the source code. Once again, go to VRig. It's a great time. And yeah, really, read the man pages. Get used to just understanding how the man pages work. Learning more in general, systemd versus runit. How processes are managed. By default, you'll use systemd. I prefer runit. You can install a Linux distro as a fun side project to help learn more. A lot of people will try that, find they don't like it, and stop. But you do it and you find you enjoy it, then you have a new operating system, and it's fun. And you don't get stuck on it forever. And learning what kernel modules do, diving into kernel space, diving into the Linux kernel itself. Most of what we learned today is in user space, what you can do as users, but there's a whole nother layer at the kernel level. And it's really fun. Once again, go to VRig. And that's it. Any questions? Thank you.